So in this question, the block is resting on a slope. It tells us that the surface is frictionless, so there's not going to be any friction involved. But the block will obviously slide down the slope. So the idea here is that we have the force of gravity acting straight down the slope. There is a normal force acting perpendicular to the slope. And those are the only two forces acting on it. Some of you might be tempted to draw an applied force. There is nothing pushing the block down the slope. It's just the force of gravity in the direction of the slope that's sort of relevant for this problem. So what we would do in this case is sort of rotate the axes. Since we're talking about a sloped surface, I'm going to rotate the axis so that my x is here and my y is here. And then I can see that my normal force is directly along the y-axis, but my force of gravity is in components. So I can say that it has an x component, which is there, and a y component, which is there. So let me try to label these on this small diagram, FGY, and then FGX would be that. And then the other tricky thing about this problem is sort of getting the angles right. But let's just try to solve it, and then we'll figure that out. So it's clear that this thing will start to accelerate down the slope, but we want to know what is that acceleration. So we're going to analyze the forces, sum of the forces, so we'll say MA equals sum of the forces. So MA equals, now the forces, and we have to pick a dimension, right? So let's pick the parallel to slope, or you could say along the slope. All right, so in that direction, the only force acting is going to be FGX. It's only going to be the x component of FG. Remember that FG is equal to mg. So we can, and then the x part of it. So if this is 20 degrees, we can see that this is 90 minus 20. And so hopefully you can by now see that this is also 20 degrees and that the x component is opposite. So we have MA equals FG is mg, and then the x component is just the sine of the angle, theta. And you can plug all this in. When you leave things as expressions, you can see that some things cancel out, and really A just equals 9.8 sine of 20, which when we calculate it works out to be 9.8 times sine of 20, 3.35. So the acceleration of the block is 3.35 meters per second squared.